Hello everyone. This is section 1.6, which is about logarithmic function. I'm hoping that this lecture is going to be slightly short. Okay, so here the logarithmic function. When you say logarithmic function, we write logarithmic function in this form. All right, this is how we write a logarithmic function. And the condition here this is log base b of x. So this the condition here is this b on the base or on the bottom. Well, this b must be greater than 0 and not equals to 1. It's similar to an exponential function. Even in the exponential function, we had similar conditions. All right. So now when we see the example of logarithmic function, when let's say we have y is equals to log base 1 over 2 of x. So is this a logarithmic function or not? Well, here it is, right? Because this one on the base is still 1 over 2 is still greater than 0. So this is a logarithmic function. What about this one? Y is equals to log base 2 of x. So is this a logarithmic function or not? This is, right? Because again, 2 is still greater than 0 and not equals to 1. What about this one right here? Log base 1 of x. So here we have base 1, so this is not a logarithmic function. All right, and the graph or the shape is always like this. So here, this is approaching towards y-axis, but it's never going to touch y-axis. So the graph is always like this kind of shape. All right, which goes through. So this point is always 1, 0. The shape is always like this, and it always goes through 1, 0. All right. So and this graph is when b is greater than 1. Another one is like this. Okay, and now again, this one is approaching towards y-axis, but it's never going to touch y-axis. And again, it goes through 1, 0, and this is in between 0 and 1. All right. Now let's go to another page. So let's say if we have let's say we want to change an exponential function to log function. So let's say if we have an exponential function like this, right? So we say this is an exponential function. I talked about this in the last video, section 1.5. So you can, if you haven't watched that, go back and watch that video, and then you can watch this video after that. So this is an exponential function. So it's exp, exponential function, and I want to change this to a log function, and let's just say log. All right. So let me rewrite this. We can also write this as 2 to the power x is equals to y. So now if I want to change this to a log function, the idea here is whatever we have in the power, we have x in the power. So whatever is in the power is going to stay on one side. X is equals to, since we are changing it to a log, so now we can introduce log, and then this 2 that is on the base of this exponential function is also going to go to the base of the log, and on right hand side we have y, so this y is going to go here. So log base 2 of y. All right. Let's say we have exponential function a to the power 3x is equals to y. Now, if I change this to a log function, this will be again whatever is in the power. Now in this case, we have this whole thing 3x and the power. So 3x is going to go to one side, and then log base. Now the base is, since we have this a and the base of an exponential function, so this is also going to go to the base of a log function, log base a of y, right here. Now similarly, let's go to the opposite way. So now let's change from log to an exponential function. So let's say if I have a log function, so it's just that you have to go to the opposite direction or opposite process. So let's see, log base 3 of y is equals to x. Then if I want to change this to an exponential function, then okay, here this thing on the base, or this thing, whatever is in the bottom, is going to move to the base of an exponential function. So on left hand side now, we're just going to have y is equals to this 3 is going to go to the base. So this 3 is going to move to the base. And now this x is going to go to the power. All right, so this is how we change from log function to an exponential function. Here we don't have any log, so we have a number on the base, a variable on the power. So yeah, this kind of function we say log function, sorry, an exponential function. All right. Okay, so the next one, let's introduce a next thing, which is called natural log. So the natural log is basically, natural log is ln, or we can, whenever you see ln, that means this is a natural log. We said this is a natural log, and the natural log is log. It's a log. It's a log, but the log with base e. All right. So what does this e means? The e is basically, it is an Euler number. A scientist named Euler introduced this number, and this number has some. It equals to some number. It's 2.1, something like this. I don't exactly remember, but it's 2 point something. All right, it's a number. Well, we don't need to know that. If you use a calculator, you'll see an option of e, so you can directly use that, or you can find it from there. I don't remember exact number, but yeah. Anyway, e is Euler number, and this is some number. E is a number. Okay, so here, so let's say if you see log base e of x, then I can, here using this fact, I can replace this log base e by natural log, right? So this I can say natural log of x. All right. Okay, now let's look at some properties of log. Okay, so the first one, let's say log base b of 1. So again, this b, I said before, the b must be greater than 0, and b cannot be equals to 1, right? This has to, well, it has to satisfy this condition. If it is a log function, then it has to satisfy this condition. All right. So log of any base, doesn't matter whatever the base is, as long as the base is base satisfy this condition, log base b of 1 is always 0. Okay. The second one, log base b of b to the power m. So this b is on the base. All right. Log base b of b to the power m. So here, this number and this number are same, right? Here we have a b, here we have a b. So if these two are same, the value of this whole thing, the value of this whole thing is always the power. So the power here is m. So that's That's the value of this whole thing. So let's say an example. Let's say if we have log base 7 of 7 to the power 3. So in this case, these two are same, 7 and 7, right? So that means the value of this whole thing is 3, because we have 3 on the power. Log base 2 of 16. So what is the value of this one? Well, here we have a 2, here we have a 16, but we can change the 16 to the 2 to the power something, right? So I can say this is also equals to log base 2 of 2 to the power 4, right? This 2 to the power 4 is 16. So now with them, we have this two numbers same, 2 and 2, right? Right. So that's why the value of this whole thing here is 4. All right. What about the value of natural log of e to the power 3? So as we know that the natural log, we said before that natural log, I can replace natural log by log base e, right? And still have this e to the power 3. So that's why here we get the value of this whole thing. Since we have these two same, so the value of this whole thing is 3. Right? Okay, now what about log of 10? So we don't have anything on the base in this case. All right, so if there is nothing on the base, there is always 10. We don't have to write it. If there is nothing on the base, it's 10. So that means this 10 and this 10 are same. So on the power, there is always 1. So that's why the value of this is 1. All right. Okay, now let's go to another one. Okay, now let's say b to the power. Okay, this b is on the base and everything else is not going to be on the power. Log this b of x. So this b is on the base and everything is in the power. So log base b of x. So now the value of this again, so since these two are same, b and b, right? So again, it's the value of this whole thing is x. So let's say if we have 7 to the power log base 7 of 6, then log base, so this whole thing is in the power and these two are same, so the value of this is 6. Okay, so now let me write this now to new page. Okay, so now here, another one, let's say we have a single log with some base and we are multiplying these two terms. A single log base b of m times n. So these m times n are these two are attached with this log. So now in this case, the properties of logs is that we can split this into two terms, log base b of m and log base b of n. But whenever we split this thing into two terms where these two are multiplying, then here we write a plus. This is m. All right. Similarly, log base b of m divided by n. So, okay, now here again, we have a single log base b of, now these two terms are dividing. So now I can again split this into two terms, log base b of m minus log base b of n. All right, another one, log base b of m to the power k. Here, this m to the power k is attached with this log. So in this case, I can move this k that is in the power down here. So this will give k times log base b of m. All right, so now using these properties, let's solve this equation. So let's solve this equation, which is, let's say, so now log base b of x plus log base b of x minus 7 is equals to log base b of 8. All right, so here in this case, we are trying to solve for x. All right, so we have a log here. So what I can do here is, well, on this side, on the left-hand side, we have 2 log with plus sign. So if we have 2 log with the plus sign, then I can combine this to a single log, but we have to multiply those 2 terms. So here we have to multiply x and this x minus 7, right? Okay, so here I have to multiply x and x minus 7. So if I distribute this x to x minus 7, the first one is x squared, and the second one is negative 7x is equals to log base b of 8. Right now, after this, now I can say after this, well, here I have just log on left hand side, just log on left hand side, just log here on right hand side. So in this case, if you have just log on one side and just log on another side, then I can just get rid of the log, because this log has this log has the base b, this log has the base b, so these two has same log. So I can easily get rid of the log. So on left hand side, we're just gonna have x squared minus 7x is equals to 8, or x squared minus 7x. Oops. 7x minus, so if I move this to the other side, minus is equals to 0. Right, so now this is a quadratic equation. So now I can solve easily, right? This is an algebra. So now here, I don't know if you guys remember, I can show that again. So just multiply a times c. A is 1, c is negative 8. Don't worry about negative just for right now. So a times c is 1 times 8. Yeah, like I said, don't worry about the negative number. Just worry about the numbers. 8. All right, it looks like since we have a middle term negative 7, so I have to use the factors of it. So it looks like I can use 8 and 1. So from here I get x squared minus, well, first and the last term is going to stay the same. And for the middle part to negative 7x, I can use this thing, negative 8x plus 1x is just x, right? Because negative 8x plus x is negative 7x. And then I can split this into 2 parts. So from the first part, x squared minus 8x, from these two, I can factor out x right here, x. The remaining terms are x minus 8. And from these two, well, I don't have anything common. In that case, I can factor out just 1, because 1 doesn't make any difference. Right? So now from these two, now I can factor out x minus 8. And the remaining terms are x plus 1 is equals to 0. So that means x is equals to positive 8, x is equals to negative 1. Right? The thing is, now after this, well, we have 2 answers. Now we need to check our answers. When you check x is equals to 8, check this to, oops, Yeah, when you check this to the original equation. So if you take this 8, x is equals to 8, it's going to work. You can do you by yourself. But when you check x is equals to -1, so you will get log this b of -1 plus dot dot dot. You can just do that on your own. So, but the thing is, log base b of -1. So log of any negative number is always undefined. All right, so log of any negative number is always undefined. All right, so that's why here this one is not going to work. So our final answer is just x is equals to x is equals to 8. Clear? All right, so yeah, like I said, this section it's going to be a short section. Um, so yeah, I think I'm done with chapter 1, which was about basically about the revision of algebra. Now from tomorrow, from next lecture, I'll start from chapter 2. I think it will start from section 2.1. Now we'll get into a little bit of calculus, the real calculus stuff. So it will get a little bit difficult from now on. All right. So you have to be more serious. Watch all the videos. Don't miss any videos because it's not going to help you. Trust me, it's not going to help you because the things are going to get a little bit difficult from now on. All right. So good luck. See you later. Thank you.